All right, hello everyone. We are on Unit 9, Imaginary Numbers. Okay. Something maybe you saw in geometry, okay, or introduced to. It deals with the quadratic formula. So we have seen that when you have a negative under the radical. Okay, those are your imaginary numbers. All right, so let's talk about where they come from. Exercise 1, you got the sketch of y equals x squared. You know what that looks like. Okay, now the parabola of the equation x squared plus 1. So we have this equation right here, x squared plus 1. So we should know what happens to this. Okay, how is it shifted? So what should happen is, because the 1 is outside, not in parentheses, so it affects the y, so it goes up 1. Okay, a quick sketch, maybe this is 1 right here, and it just goes like that. Okay, goes up 1. Now, in the original graph, it went through 0, 0, which is the x-intercept. Now, when that moved up 1, what happened? There are no x-intercepts. Now, it's not that they don't exist at all. It's just that they don't exist in the real number system. Okay? So that's what it's saying here. These intercepts do not exist in the real number system, but they are imaginary numbers. So if you wanted to solve this quadratic, anytime you have an x squared, only an x squared, you can bring the other value over. So I have x squared equals a negative 1. So then I square root, x equals plus or minus square root of negative 1. Okay? But that doesn't exist, right? You put in your calculator square root of negative 1. I don't know if it says error or imaginary. I'm not sure what it says in the newer calculators, but it doesn't exist in the real number system. Okay? And that only works if you do not have a b term, a bx, right? Ax squared plus bx plus c. So if you just have an x squared, you can do that every time. All right, so here we have the definition of the imaginary number I. So I equals the square root of negative 1. So if you look back up here at this answer that we just solved for, okay, the x value would be plus or minus I, because it is the square root of negative 1. So whenever they want you to simplify, or when you're using the quadratic formula to simplify, you have to make sure that if there's a negative under the radical, you take that out. We're going to see a form that wants everything with an I as an answer, so you want to get in the habit of taking out that I, okay, or the square root of negative 1. So when you go to simplify these, always take out the negative 1, and then you just have the square root of 9. Okay, what does that give me? That gives me the I3, and then it's just 3I. Same thing here. Take out that negative 1, you have the 100, 10I. Simplifying, now you're like, oh boy, what's going on? It's not a perfect square. So you have to find the perfect square that goes into 32, which is 16 and 2. So square root of 16 is 4, square root of negative 1 is I, and then you have root 2. So that's the order you want to put it in. Treat it like a variable, wherever you would put a variable. Now the square root of negative 18, you have your negative 1, you have your 18, 9 and 2. So square root of 9 is 3, square root of negative 1 is I, and then you have the root 2. 3I root 2. Okay? So that's how you would simplify when you have a negative underneath the radical. Like I said, some of you have already been doing this. Okay, you've already seen it. And here's some more quadratics when you're solving. Again, there's no b term. So that's why they call it an incomplete quadratic. An incomplete quadratic means that it's just ax squared plus c. There's no bx term. And we want to make sure that they are in simplest radical form, not a decimal. Okay, simplest radical form. Okay, so what do we have here? Bring the 8 over. We have a 5x squared equals negative 20. Divide by 5. We have x squared equals negative 4. And then square root. X equals the square root of negative 4. Okay, plus or minus, and so x equals plus or minus 2I. Because the square root of 4 is 2, square root of negative 1, of course, is I. Next one. Okay, I'm going a little fast. It's not a very difficult problem, you know. So if you need to rewind it slow, whatever. All right. So bring the 20 over. So you have 1/2 x squared equals negative 18. All right. Multiply both sides by 2. So we have x squared equals negative 36. Square root. X equals plus or minus 6i. Okay. Last one, letter C. Bring the 10 over. We have a 2x squared equals negative 26. Divide by 2. X squared is negative 13. Square root. Okay, so x equals plus or minus I root 13. Because you can't break down the square root of 13. Sometimes you'll see it written as plus or minus root 13i. Just be very careful that the I is not underneath the radical. Okay, so be careful of that. All right, so combining these, all right, like I said, treat them like variables. Okay, so you have a 5i times a 6i, just like 5a times 6a. Okay, it would just get 30a squared, so this would give me 30i squared. So then you look at your choices and you see that 30i squared is not a choice. So that means we can simplify this I squared. I is the square root of negative 1. So we have 30 times the square root of negative 1 squared. So if I have a square root squared, they cancel. So then I just have 30 times negative 1, which gives me choice 3, which is negative 30. Okay? And you could also just put that in your calculator. All right, so if you put this in your calculator, oh, I got to move this over so you can make sure you can see it. Okay, so the I button is underneath the pi. See it right there? So make sure that you don't use, how do I get out of there? Don't use the I in here with the letters. Okay, so we have 5I times 6I, enter, negative 30. Okay, so you can use your calculator to help you out, or even to solve for you. That's fine. No problem, especially on the multiple choice. No big deal. Okay? Now, I to the first power. Okay, simplifying, so powers of I. Because it's not only going to be, 1, 2, 3. All right? Now, what we start with first, though, is I to the 0. And we talked about this last week. What's anything to the 0 power? 1. Okay, anything at all. I to the 0 is 1. I to the first is I. Anything to the first power is itself. I squared, I just showed you what it was, is negative 1. Now, I cubed. What you would do with I cubed is you would use what you already know. So I cubed would be I squared times I to the first. Okay, I squared is negative 1 times I gives me a negative I. I to the fourth, you want to use what you already know as well. I'm going to go with the easiest one. You could do I cubed, I to the first. I'm just going to do I squared times I squared. Easiest one to do. Negative 1 squared, which is just 1. Now, when you got to I to the fourth, do you see how it's the same as I to the 0? So what it is a recurring pattern. Okay? So if you do I to the fifth, right? I to the fifth is I to the fourth times I to the first. So we have what? 1 times I. So I to the fifth is just I. I to the fourth went with I to the 0. 1 and 1. I to the fifth is the same as I to the first. So what do you think I to the sixth is going to go with? I to the sixth is going to go with I squared, which is negative 1. I to the seventh will be just like I cubed, which is negative I. And then I to the eighth is back to I to the fourth, which is 1. So it's a recurring pattern. Now, the pattern here, you're going to have a negative 1, a 1, an I, or a negative I. Okay? Now, what I like to do, let me move this over again a little bit. Okay. What I like to do is I like to do I0, I1, I2, I3. because the first two you can get easily. Anything to the 0 power is 1. Anything to the first power is its side of the first is just I. I squared, which we already saw, is -1. And then I cubed is -I. So 1I, -1, -I. Now, what you want to do is you want to find a remainder, so to speak, okay? Or the decimal that's left over, okay? Because I think that'll be the easiest way in your calculator. Because we're not just going to have 0 through 8 as the power. They're going to be higher powers. So I say this is a 0.00, this is a 0.25, this is a 0.50, this is a 0.75. Okay? So when you look at the example in your notes, okay? Where are we? Here we are. I to 38. Okay? You want to go through and do the pattern, go on and on and on and on, fine, go ahead. What we would like to do is you take 38, and it's a pattern of 4, right? So 38 divided by 4 decimal. Enter. You get 9.5. I'm not worried about the 9. I'm worried about the 0.50. And 0.50 is -1. Okay? So that means that I to the 38 is -1. Okay? And if we put it in, I to the 38, -1. Okay? Yes, anyone could just plug it in the calculator, but when you get to higher levels, you're going to need to know what they mean without just putting it in the calculator. So with 21, and we'll be able to do it quicker too, right? I to the 21, all right? We have I to the 21. 21 divided by 4, okay, is 5.25, right? Okay, the 0.25, boom, 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 is I. Okay? So there's your I. 83, oh my gosh, it's too big of a number for some of us to do. So we have 83 divided by 4 decimal, and you get 0.75. Our 0.75 is -I. So there is -I. I to the 40, 40 divided by 4, 10 comes out to be a whole number. So it's 0, okay? So you are just back to 1, okay? So it's a little quicker if you know the methods, the 0.00, 0.25, 0.85, 0.75. It'll be quicker than just always putting in your calculator. So in the beginning, you might have to always put in the calculator, which is okay. All right? So equivalent to, so we're adding these together. I to the 16, right? 16 divided by 4 is 4. Okay, so that's just 5 times 1 plus 3I to 23. 23 divided by 4 is 5.75. Okay, so we have 3 times -I. And then plus I to the 26. 26 divided by 4, all right, gives you 6.5. So you have your 0.5, which is -1. Okay, now we have 5 minus 3I minus 1, and we get 4 minus 3I, which is choice 2. Okay, so again, I know it's might be a little confusing in the beginning, but you can always just put it in the calculator as well. Like if you put the whole thing in here, okay, I'm almost out of time. You put it, let me see if I have enough time to do it. Let me pause. I hit enter too quick. Okay, so there it is. There's your 5I to the 16. And then you have plus 3I to the 23rd, plus I to the 26. Okay, put it in your calculator, you get 4 minus 3I. And that's how they show it. And the I will always come second. Okay? All right, so there you have it. There's lesson 1. All right, we'll work on some fluencies in class. All right, we'll see you in class.